Another thing that we haven't done in Visual Studio is to use external assemblies that for which we can get updates from NuGet. So NuGet is sort of a repository of different programs you can use, and we're going to be playing around a little bit with one of them here. So bottom line is that unit tests in Visual Studio rely on two programs, two assemblies that that the people at Microsoft have built. One is called MS Test Test Adapter, and the other is MS Test Test Framework. So what we're going to do here is make sure that we have the right NuGet packages installed. So here's the way that works. We come here to the unit test project. That's the one that has this, it looks like a little, a chemical flask or beaker. And we're going to right click on the project name. And down here, right under Add, you see Manage NuGet Packages. So click that. And you'll see that you've got these two packages installed. So we've already got the test adapter and the test framework. But it turns out that if you're running an old version of the test adapter and test framework, your tests may not run. So if you look over here, you'll see, oh, well, we're running 1.3.2, but 2.1.0 is the current version. So let's make sure we've got everything updated. So I'll click on Updates and then select all packages. When you click Update, you'll get the license acceptance panel for both of these things. So I'll say I accept. And now we have the latest version of the test adapter and test framework. So that gets us to the point where we're actually ready to begin building unit tests. So I'm going to close this window. You already know we've got that. And this is important. Depending on what version of Visual Studio you have and what versions you have of NuGet and all that stuff, things might be a little bit different from what I just showed you. So if you have problems with these steps and have difficulty completing the assignment at the end of this, please let me know in the discussion or send me an email. I prefer that you say something in the discussion because then if there are others who are having the problem, they'll be able to benefit from what you've learned. All right. So now we need to tell the unit test project where our project under test lives. So we want to test this Find Price Ride Along project that's got the Find Price Ride Along class that includes this Find Price per Anvil program method. So what we'll do is here on Unit Test Project, we'll right-click References and select Add Reference. Then we come here to Projects and Solution and select the project that we added up here that holds the software we want to test and click it. Okay, and now you'll see that there is a reference here to Find Price Ride Along. Next, we're going to add a using statement that enables us to use the Find Price class. But this is going to look a little different from the using statements we built before because this establishes an alias. In test-driven development, it is a convention that you use the abbreviation SUT for the software under test. So instead of, well, you'll see. Let's just do it here. We'll say using SUT equal find price ride along dot find price class, the name of the class that our method's in. Okay, now we're all set up and ready to start building tests. So as we build the test cases, there is a convention, a naming convention used in test-driven development. And you'll find that different practitioners use slightly different conventions, but these are the ones I'm going to use. The name of the test class is going to be the method name that you're testing with an underscore should. And then you'll build one class for each method being tested. So in this case, it's find anvil price, I think. And then one method for each test case. So the name of a test case would be something like return 80 when quantity is 1. And then each test case is given three parts: arrange, act, and assert. And you'll find that that practitioners of test-driven development expect to see these three segments of each test. In the arrange section, you get things ready to call the method under test. So you're setting up all the input parameters and anything else that needs to be set up. In the act section, you call the method, and then the assert section, you test to see whether you got what you expected. So here's the test plan. And as I said, we're only going to build these first 5 tests. So let's go ahead and take a look at the code and build a test. So the name of the class right now is unit test 1, but I want to change that to find price per anvil underscore should. So find price per anvil is what we're going to be testing. And then the first test, we'll go to this first test case in the test plan where the quantity coming in is 1 and we expect a return of 80. So find price per anvil should return 80 when quantity is 1. Okay, and now we'll code the test. So the first part is arrange. And we'll say, okay, we need an integer called quantity. We'll need a decimal, and we'll call it expected result. And we'll initialize it to 80 because that's what we expect to have come back when we send in a quantity. Oh, I'll initialize this too, a quantity of 1. And then we need some place to store the actual result. So we'll call this return result. Okay, so now we've got everything set up so that we can make our call to the first test. And then we'll write the action. So what we want to do is say return result equal, then find, SUT dot find price per anvil. So now we're saying it's the software under test as described here and the find price per anvil method in that software under test. And we'll send in its quantity like so. and then the assert part. So here we're going to use a new statement called assert. So we're going to say assert.r equal. And what I want to be equal is the expected result and the returned result. If they're equal, then everything is good. If they're not equal, the assert is going to fire, and we'll see that the test will fail. All right, that's it for this video. We'll continue building the other tests and actually run them in the next one.